symmetry. Search your static love, growing like weeds. Study shapes built into your ear. The coast is clear, the coast is here. I wanna die on this shore and stare at this country of ours.
Hey, it's Professor Dave. Let's talk about calorimetry.
He knows a lot about the science stuff. Professor Dave explains.
Different substances absorb heat at different rates due to various structural factors. The heat capacity of a substance is the amount of energy required to raise the temperature of that sample by 1 degree Celsius. A variation of this that is more useful for calculations is the specific heat of a substance, which is the energy required to raise 1 gram of a substance by 1 degree Celsius. Heat, temperature, and heat capacity are all related by the following equations. The amount of heat exchanged in a reaction is equal to the heat capacity of the substance times the change in temperature for that substance. Or, more practically, the heat exchanged is equal to the specific heat of the substance times the grams of the substance present times the change in temperature. We can use this information to learn about heat transfer using a process called calorimetry. For those of you in an introductory chemistry course, you'll probably do some variation of a coffee cup calorimeter experiment. Let's look at how those work. A coffee cup is a pretty good insulator. That's why we use it for coffee, so that the heat doesn't escape so quickly and the coffee stays hot for longer. This makes it possible to take pretty reasonable data about the temperature change in a cup of water when we add a hot piece of metal. We can measure the temperature change in the water and use that information to calculate the specific heat of the metal. So, let's say you heat up a metal by placing it in boiling water at a known temperature until it is just as hot as the water. Then, with tongs, you place it in a coffee cup containing a known volume of room temperature water with a thermometer. The water in the cup will heat up slightly as the heat from the metal flows into the water, and we can record the resulting temperature change. From there, we just do some math. We use the specific heat equation and plug in the data for the water. The temperature change is what you recorded. The mass of water in grams is equal to the number of milliliters of water. And the specific heat of water is a known value. This allows us to calculate the heat absorbed by the water. Well, the heat absorbed by the water was the heat released by the metal. So we can take that same quantity of heat and plug it into a new equation for the metal. That value goes there. We weighed the metal beforehand, and this time the temperature change of the metal is from the boiling water to the final temperature in the coffee cup. So you can solve for the specific heat of the metal. This is useful for identifying unknown metals if you are given a few different specific heats and asked to decipher which metal you are given. Let's check comprehension.
limitations of specific heat capacity. Since water is able to take in a lot of heat, it is ideal for use in the cooling system of motor vehicles, such as cars. Figure shows the cooling system of car engine. Water is circulated around the cylinders, absorbing heat from them. The hot water is then cooled down again as it passes through the long metal tubes of the radiator. The cooling is aided by air sucked in from outside by the radiator fan. Since water can store a huge amount of heat, it can also be used as a heating agent. During winters, water from hot water tanks is directed to water pipes and radiators fixed inside the house. The heat radiated from the radiators can help to warm up the house to a comfortable level. The cold water is then directed back to the hot water tanks to be reheated. Cooking utensils are normally made of metal, because metals have low specific heat capacities. The low specific heat capacities of metals enable its temperature to be easily increased when heated. Metal that are suitable to be made into cooking utensils are aluminum, copper, and stainless steel. They are suitable because they are non-toxic and do not rust.
The quantity of heat required to raise the temperature of unit mass of a substance by 1 degree Celsius is called its specific heat capacity. The specific heat capacity of water is 4200 joule per kilogram degree Celsius. Thus, 4200 joule of heat is required to raise the temperature of 1 kilogram of water by 1 degree Celsius. There are several applications of high specific heat capacity of water in everyday life. Formation of land breeze and sea breeze. The specific heat capacity of water is about 5 times more than that of sand. During daytime, sand gets heated more quickly compared to water. The air layer associated with sand becomes hot and rises up. This causes the sea breeze to move towards the land. During night, as the sand cools much faster than water, the air layers above the water are hotter than the air layer above the sand. Therefore, they rise up and land breeze moves towards the sea. Hence, a moderate climate is maintained near the seashore. Fermentation. As water has high specific heat capacity, it absorbs a large amount of heat when its temperature rises. Also, when the temperature decreases, water gives out large amount of heat. Due to high value of specific heat capacity, water takes longer to cool down. For this, we use water in hot bags for fermentation purposes. Coolant. Water is used as an effective coolant by letting it flow in pipes around the heated parts of a machine. Example, radiator of a car. When there is a rise in temperature, water extracts more amount of heat owing to its high specific heat capacity. To avoid freezing, in cold countries, wine and juice bottles are kept underwater to avoid freezing because water does not cool quickly owing to its high specific heat capacity. Did you know? The high specific heat capacity of water regulates the extremes in the environment. For instance, in ponds, the heat capacity of the water helps regulating the temperature of the water and keeping it relatively the same from day to night. Protection of crops. Farmers protect their crops from frost by filling the fields with water during winters. Since the specific heat capacity of water is high, the temperature of water does not decrease much on a cold night. Thus, it does not allow the temperature of the surrounding area of the plants to decrease. Metals like copper, aluminium, iron, etc. are good conductors of heat, and they have low specific heat capacity. Therefore, cooking utensils are made up of these metals, so that they can quickly attain a high temperature for a known quantity of heat supplied. Specific heat capacity is the quantity of heat required to raise the temperature of unit mass of a substance by 1 degree Celsius. The specific heat capacity of water is 4200 joule per kg degree Celsius or 4.2 joule per gram degree Celsius. Due to high specific heat capacity of water, land breeze and sea breeze are formed. Water is used in fermentation bags because of its high value of specific heat capacity. Water extracts more amount of heat due to its high specific heat capacity and thus is used as a coolant in hot machines. Water is used to preserve wines and juices because it avoids freezing by not cooling quickly. Specific heat capacity of water is high and it does not allow the temperature of the surrounding area of the plants to decrease.